So to understand why we might be interested in this, let's go back to that race example. And let's say that instead of wanting to select a top 3, wanting to select the medalists, you are under contract with Nike and are looking for people to sponsor. So you're looking for 3 people to select, and presumably the sponsorships are going to be all about the same. So it doesn't really matter who you pick first, second, or third, they're all getting roughly the same contract. In that case, order is irrelevant. And if order is irrelevant, then we work with what are called combinations instead. Where for combinations, we take all of our options and we divide out the remainder, the ones that we're not picking, and then we also divide out the arrangements within those we select. Because first, second, third is the same as third, first, second is the same as third, second, first, is the same as second, first, third, if we don't really care about how they're arranged. It's just a selection of 3. And I'll say that with the notation here, sometimes we do look at these combinations as C and R in much the same way as permutations I mentioned. And then also we'll occasionally talk about these in terms of notation for a thing called the binomial coefficient. For us, we're mostly looking at that guy, but these two are also valid and worth mentioning. In any case, if we specifically want to talk about the runners for the race, well, we would have 8 options that we are selecting 3 from. So that would be, in this case, 8 factorial over 8 minus 3 factorial times 3 factorial, because we don't care about the order in which those 3 are selected, we're just picking them. And as a result, we would get 8 factorial over 5 factorial times 3 factorial, where the 5 factorial goes into the 8 just like before, except this time we now have 8 factorial, or excuse me, not 8 factorial anymore. We will have 8 times 7 times 6 over 3 factorial, which ends up being just 56. I'll leave you to check that 3 times 2 is 6. Hope you can get there. But the important thing to notice here is when it comes to these computations, when it comes to these numbers, we almost always have that if we're selecting versus permuting, if we're looking at n choose R, and we usually say this as n choose R instead of n combine R, whereas in the other case we might say n permute R. But generally, we have that permutations for the same number from a group of the same size give far more options, which, if you think about it, should make sense. That if all you're doing is selecting groups of things, you won't have as many as if you care about the way those things are presented. And to see this a little further, we're going to look at another example. So here we have that funding is organized for a new scholarship and it receives 16 equally qualified applicants. The selection committee plans to accept 4 of the applicants, where we want to find how many different combinations can be selected from the 16. And we're making the assumption here that for those 4 selected, there's no special arrangement of the scholarships. They're all equal, so whoever gets it first is the same as whoever gets it last. Except that maybe the person who gets it last will be a little bit more stressed, but, well, financially they're in the same boat. Anyway, for this, because order doesn't matter, we use combinations. That is, we're going to be looking at taking the 16 applicants, so n equals 16, and selecting, choosing r equals 4 of them. So we're looking at 16 choose 4. And when where working with this, we will have 16 factorial over 12 factorial times 4 factorial. So you got that 4 there, 16 minus 4 is 12. And then we're going to pull that 16 apart. 16, 15, 14, 13, and 12 factorial over 12 factorial times 4 factorial. So the 12s are going to cancel, and we'll be left with 16 times 15 times 14 times 13 over 4 times 3 times 2 times 1, just to be clear that there is a 1. And then you can start canceling some terms. The 4 would catch on the 16, the 3 would catch on the 15, and the 2 would catch on the 14. So you'd be left with 8 times 5 times 7, which would end up being, I believe, 280, and then you multiply that times 13, and you would get 1820. Where I'll say that for these examples, I've done them all by hand so far, just to show you how you can do them by hand. And they're not that bad to do by hand, really. It's kind of important to see how these things work in that way as well. But I will also say that they're pretty easy to do on the calculator, and you're going to see how to do that as well in another video. But we're going to finish this section, this chapter, by tying this work back in to things that we can do with probability.